So today we're going to be working on Kinetic and Potential Energy worksheet. Make sure you put your name, date, and hour up here. So make sure we got a little name, date, hour action here. And after you get that on there, we're going to have to figure out a few formulas. So we need to know that kinetic energy, KE, is going to equal the mass divided by 2. And we're going to put that into a quantity, very much like we did our mousetrap car. And then we're going to have the velocity, which is going to be squared. So that is our first formula that we're going to see. We also need to know that this usually gives us the unit of joules. And a joule is broken down into a kilogram meter squared over a second squared, like this. We also need to know that a newton, a unit of force, is equal to a kilogram meter per second squared. So a newton's a little bit different than a joule. Okay? Notice that it's here and it's set up in such a way so that a joule equals this, but a newton equals a kilogram meter per second squared. So we have to have a newton. A newton is a measure of mass that gravity is pulling down on. Okay? And so we get this unit of a kilogram meter per second squared. And then from there, we need to know that a joule is also known as a Newton meter. That means it's a Newton times a meter. So it's a distance that it travels. So an Nm, or Newton meter. And then the last thing on here that you would need to know that would be background information would know that gravity, G, equals 9.8 meters per second squared. Sometimes you'll see it as a little g. Sometimes you'll see it as a big G. Just kind of depends on who's working on the actual formula. We've also got something over here that says two different formulas here, and this kind of is just a variation of what you see up above. This is the kinetic energy of 1/2 the mass times velocity squared. And another way we can find potential energy is mgh, and then another way we can do it is the FWH. Now, force weight is how much gravity pulls on the mass of an object. Okay, so that's what FW means. It's the weight or the force created by the weight of an object with gravity being pulled into it. So when we hear weight or we hear a force weight, that means that gravity is pulling on it and it's already multiplied the mass times the 9.8 meters per second squared. So that part's already been done for you. And that's why we see this in this formula. So when we go to work these problems, we have to figure out first what are we finding. In the number 1, it says you serve a volleyball with a mass of 2.1 kilograms. So what we'd want to do is we want to highlight the mass, 2.1 kilograms. And we could label this as the mass, like that, like an M. The ball leaves your hand with a speed of this, and so this is the speed and velocity are the same thing. It doesn't give you a direction. We know the direction is away from your hand when you hit it, so this would actually be our velocity that we have. And then the ball has blank energy. So when the ball is moving, does it have potential or kinetic energy? Kinetic energy. So you would want to write kinetic and finish out the part here. So we want to go ahead and put that in. Let me make my E look a little better. And you have kinetic energy. And then it says calculate it. So we want to find the kinetic energy. So that tells us that kinetic energy, KE. And we're going to put our formula of m divided by 2. And then we're going to take the velocity and we're going to square it. So first you would write your formula down. And then from here, I would say you would be working it onto a sheet of paper, but we're going to put two examples on here then the rest of it will work on another sheet of paper. So let's go back up and let's look and see, well, what is our mass? We know that our mass is 2.1, and this is kilograms. And we're going to divide that by 2, and we're going to quantify it like this and put it into parentheses. And then we're going to multiply that number times the velocity squared, which is 30 meters per second. So we put 30 meters per second, and we're going to square that. And so we come over here and we take our mass of 2.1. We're going to divide it by 2, and that's going to give us an answer of 1.05 kilograms, like so. And after we do that, it's going to be multiplied by, well, if we take 30 and we square it, well, 3 times 3 is 9, plus 2 more zeros gives you a total of 900. And if we square the number, we also square the units of meters and seconds, so we would get meters squared over seconds squared. Hopefully that's ringing a bell with you from what we have done before. Remember, anytime you have a square, everything inside the parentheses has to be squared, not just the number, but the units as well. And so now we can just look at this and we can multiply the two numbers together, and that's going to give us 945 kilogram meters squared over seconds squared, which equals 945 joules of energy. Because remember, we're looking for energy right now. We're not looking for anything else. We're just looking for energy. And it's a joules of energy. Number 2, we would take our highlighter and we come over here and we read through a baby carriage that's sitting at the top of a hill, 21 meters high. Why anybody would leave the baby carriage alone on top of a hill, I have no idea. But the carriage is with the baby weighs 12 newtons. So now we know we have weight, right? And then the carriage has blank energy. So we also on this one know that this is going to be potential, correct? Because it has the potential of rolling off the hill. Now hopefully it doesn't roll off the hill. We don't want a baby to be hurt. But now we see that this is weight. Remember we said that force times the mass gives you a weight of an object. So we're going to use a different formula. We're going to use this one right here. We're going to do PE equals FWH. So in this case, we would do PE equals FW, which is the force weight, times the height. And so these problems are really simple. They're just two variables. The first variable is going to be the force weight. We know that to be 12 newtons. But what is a newton? A newton is a kilogram meter per second squared, correct? So we're going to put that, we're going to change the newton into a kilogram meter per second squared whenever we work the problems. Kilogram meter second squared. And then we're going to multiply that times our height, and their height is 21 meters. And I'm going to put it over 1 just to keep it in alignment with the units, so the units are all in the right place. And you can do that to the same thing over here. Now they're all in alignment with each other. You could have a multiplication sign here if you wanted to, or a dot in between. Either one would be fine. And then we come back, we multiply 12 times 21, and we know, look at that, and we see that 12 times 21 is 252. That would be in the numerator. And then we're going to have a kilogram. Now what is a meter times a meter equal to? Meter squared. And then S squared times 1 is just S squared. And we know, here's our little thing that we have again, the kilogram meter squared over second squared, we know is a joule, 252 joules of energy. And we would box that in like so, and that would be our answer. So these are all the steps that you must do. If you don't do those, and you don't show that this is 252 kilogram meter squared over second squared, you lose points. And then if you didn't put joules at the end, you also would lose points. Now these would all be written onto another sheet of paper. Okay? Like what we're doing, we don't have a lot of room to do the invert and multiply and stuff like that, but we'll talk about those as we go. So next I'm going to kind of just work through some of these others, and I'm not going to do a lot of the things for you. I'll let you fill in a lot of it, and you can write down formulas as we go. So number 3 says a car is traveling with a velocity of 40 meters per second, and it has a mass of 1,120 kilograms. The car has blank energy. I'll let you fill in what type of energy you think it is, because the car is traveling or moving. And you can write in that correct answer. And then over here, we notice what we have this. We're looking for a certain kind of energy. And so you're going to have a formula that's going to be like this. It's going to be kinetic energy formula. And I'll let you write that down, write out the rest of the formula on there, put kinetic energy and does that. That way you can find it. Number 4 says a cinder block is sitting on a platform 20 meters high. And it weighs this much, 79 newtons. The block has blank energy. I'll let you put in that answer, and then you're going to have to calculate out, and you're going to have to pick which one of the formulas you need for potential energy. Is it mass times gravity times height, or is it force weight times the height? It depends on what they give you. In this case, they give you height, and they also give you newtons. So some of it has already been done for you. Number 5, we're going to have 45 meters is going to be the height. And, you know, if you wanted to write these in, you could actually put H underneath it. And then over here, we could say that this is going to be the force weight right here. And then the last thing you would do, it says the bell has blank energy. And you'd have to write down what type of energy it is. Number 6. Number 6 is basically another type of problem, very similar to this. It says a roller coaster is at the top of the hill, and it's 72 meters high. And it has a weight of 996 newtons. Remember, if it's weight, it must be FW, correct? So that tells you that this has to be FW. And that helps you out on figuring out your formula. So you can go ahead and put in that formula for it. Number 7. Number 7, what is the kinetic energy? So we know what we're looking for, right? We're looking for kinetic energy. And a lot of times what I'll do is I'll just put a question mark underneath that. This right here, 3 kilograms, that of course is the what? Mass, right? And the ball is rolling at 2 meters per second, which we know that that is a, since it's written out, it'd be 2m over s, and that is a velocity. So we've got mass and velocity, but we do not have, we do not have the kinetic energy. So we would want to come over here and do kinetic energy. And then your formula on that, of course, is m divided by 2. And then we would take our old friend, the velocity, and we would have to square it. And you'd work that out on paper. Right? Just like number 1. So you're going to work that out just like number 1's worked out. And number 8 says the potential energy of an apple. So we know that that is going to be potential energy is what we're looking, or it says the potential energy of an apple is 6 joules. So we know the potential energy, or PE, is that. It says the apple is 30 meters high. I'm sorry, 3 meters high. Sorry. And so 3 meters high is going to be H. And then the last part says, what is the mass? So we're looking for the mass. And if we're going to work this problem out, we are going to have to use a triangle. Okay? And so with this triangle, we know that on this that potential energy equals M, G, and H, mass, gravity, and height on number 8. But we have to rearrange this. So we want to set up a triangle that looks something like this. And at the top of it, we want to put potential energy. And then underneath that, we're going to divide it into 3 sections, like so. So this is a little bit different triangle than what we did before. I do have it written on the board up there if you want to see a little, maybe a bigger picture of it than what you see on the screen. And this is where our M, our G, and our H are going to go. So in this case, it says the potential energy. We know the top one. We know the meters, which is the height. Well, and we should know gravity, right? Everybody knows gravity is 9.8 meters per second. So what we're looking for is M, correct? So you would put your finger over the M, and whatever is left is your formula. So I would say M equals the potential energy divided by, because notice that this is on top and these are below, the potential energy divided by gravity multiplied times height. And then you would put an equal sign, and then you would work this out by putting in your numbers. Now remember, we started out with joules, so this is actually going to be a kind of one of those weird things. We have to kind of break down the joules and say, okay, we've got 6.00 kilogram meters squared divided by seconds squared. And then underneath that, remember these all go like this. That's the top fraction. So it's going to be one of those fraction divided by a fraction. We're going to have 9.8 meters per second squared. I'm sorry that it's kind of hard to see right here. And we're going to multiply this times 3 meters. So 3 meters over 1. So if you take the 9.8, we're going to put an equal sign, and then you would work this out by saying, okay, this is 6 kilogram meter squared divided by seconds squared. And we're going to multiply this by the reciprocal of the bottom one. So if you take 9.8 and you multiply it times 3, didn't do this on the other video, so we'll do it on this one. So 9.8 times 3, I get 29.4. So we would have 29.4, and that 29.4 is going to be on the bottom, 29.4, and it's going to be meters squared. And then on the top part is an S squared, which is here, like that. Now that's me flipping it over. So I did the reciprocal of this. 9.8 gives me 29.4 meters squared divided by seconds squared. And so all I did was just take that and just flipped it over. And when I flipped it over or got the reciprocal of this, we then would take this number and divide it by that number. And look at what happens. We get a cancellation here. We get a cancellation there. And what are we left with? Kilograms. And so over here we're going to have an answer in kilograms. Now, your paper will look a lot cleaner than this, because you're going to be on lines of paper where you can show the invert and multiply, or they're multiplying by the reciprocal. So once you get your answer right here in kilograms, we'll move over to the next one, which is number 9. Number 9 says there's 2 objects that are lifted by a machine. One object has a mass of 2 kilograms. So you've got one mass right there. And then it says lifted at a speed of 2 meters per second. So that tells you that that's going to be your velocity. So you got a mass over here. So this is mass, this is velocity right here, so this is a velocity. And then over here, your second item is going to have 4 kilograms, and then it is lifted at a rate of 3 meters per second. It says which object has more kinetic energy while it is being lifted. So when we go to this problem, we're actually looking for kinetic energy. So this will be 2 problems in one. How much kinetic energy while it's moving upward, being lifted by a machine. And so we would come over here and we would say kinetic energy equals your mass divided by 2, which we already know is over there. And then we also have a velocity. And so your velocity goes in there. So we're going to have velocity squared, like so. You don't have to put it over 1, but you can if you want to keep it in alignment. So you're going to have one problem there where this is going to be, the 2 is going to come in for the mass. The velocity is going to go in from here. And then you're going to have a second problem you're going to have to work. So on problem number 2, we'll have kinetic energy equals m divided by 2. And then the velocity squared, and then you'll work that problem out. So I've given you both formulas that you need. You can work those on another sheet of paper, one beside each other. And it basically says they're lifted, blah, blah, blah. It says the order comes out. It says which object has more kinetic energy. So whichever one has the most kinetic energy, then put a star by it. And we'll make that worth a couple of points as well. 9 part B says which object have more potential energy. So well, we're going to come over here and we're going to say potential energy. And we have the mass, and we have velocity. And so we got kinetic energy here, we got the mass, we got velocity. So we want to do potential energy. And so when we do potential energy, remember that potential energy is going to be mgh, mass times gravity times height. And we know the mass of the object because it's up here. So if we were to do the first one, you would take the mass, and that goes here. You know the mass, let's see, mass, and here's the velocity. But we also know the mass here, and we know the height. Make sure. We know that the height is 10 meters, right here. Gravity, you know, is 9.8 meters per second squared. That goes in for gravity. And then you work one there, and then you'll have to work one for the other one. So you're going to have another problem that would be potential energy is mgh as well. And we're going to use the height again, right here, because you lift them the same distance. And then the mass of this one is 4 kilograms, so that would be the mass. And then we also have the gravity for that one. So that kind of gets marked up quite a bit on that problem. Thus the reason why we work these on a piece of paper and make sure that they're worked out so we can solve. So this is the back side of the sheet. We'll work this on day 2. This shows you different things that are done. This is a velocity problem, so you actually have to rearrange this to get this. Velocity equals the square root of the kinetic energy divided by the mass squared. And some things will cancel out. And then you'll end up with your actual velocity. And then you're going to do a kinetic energy again. You're going to do a height problem. So here's some other stuff here, and I'll have this posted, this video posted if you want to look at it. Here are the rest of the formulas. Going up to number 13 is kinetic energy. 14 is a velocity problem, which is just like number 11. 15 is a mass problem. And we will talk more about this tomorrow on day 2 of this video. And on number 16, it gives you all the information you need to do potential energy, kinetic energy, and then kinetic energy again if you have a change in velocity. And so that is all I have for you on the video. And tomorrow we'll work these out in class. I'll talk to you and show you more about them, okay?